Hello everybody, welcome to this video lecture session where I am going to explain you the point method or geometric method of elasticity of demand. There are a number of methods measuring price elasticity of demand and point method is one of them. The simplest way to explain this method is to consider a straight line demand curve. When a point is plotted on a demand curve, it divides the curve into two segments. One of them is always the upper segment and another one is obviously lower segment. After that, the point elasticity is measured as the ratio of lower segment to upper segment. The formula is displayed on the screen and this formula will be used to measure the point elasticity. Please note it down and remember, otherwise you will not be able to understand the remaining explanation. Olab agote moi koisu je etu methodot ami eta rokhik ba sidha sahida rekha lobo lage. So the straight line demand curve is displayed on the screen. In the when you draw the demand curve, we know that on the x-axis we take the quantity demanded and on y-axis we take the price. AE is the demand curve touching both the axes. There are 5 points of the demand curve: A, B, C, D, and E. Okay. Let us assume that that C is the middle point of the demand curve. So we can say that this point is dividing the curve into two equal halves. Okay. Let us start from the point A. When point A is considered, the lower portion of the demand curve is the entire curve because A is the first point or the starting point of the line. Therefore, we don't see any other upper part. There is no upper part. No upper means zero upper. So, elasticity at the point A is equal to AE divided by 0. Yet lower part AE, upper part ekku nai karone 0 likhisu. Ete ami janu je anything divided by 0 is always infinity. So, at the point A, we can say the numerical value of elasticity is infinity. Now let us come down to the point B. Here the lower part is BE, whereas the upper part is AB. As BE greater than AB, so we know that any larger value divided by smaller value is always greater than 1. So at the point B, the elasticity value will be greater than 1. Now come down to the point C. Here lower part is CE, but the upper part is AC. We have already assumed that C is the middle point. So obviously CE is equal to AC. Any value divided by same value will be equal to 1. For example, 2 divided by 2 is equal to 1. But 9 divided by 9 kiman hobo? 1 hobo. So hekarne at the C point out ami elasticity value 1 likhisu. Now again come down to the point D. Lower segment yat kiman? DE. Upper segment AD. We see that DE is smaller than AD. So any smaller value divided by larger value is always less than 1. For example, dhara k 1 divided by 2 is equal to kiman 0.5 hoine. So hekarne yate elasticity less than 1. Finally we come to point E, and E is exactly on the x-axis. It is why there is no lower segment, entire curve is upper segment. Gote AE portion to a upper segment. So we have written 0 divided by AE. Ami janu je 0 divided by anything is always 0. So elasticity at the point E is 0. In this way, we have been able to locate or calculate the 5 degrees of elasticity value. Eta kotha tumaloke notice kora jimane ami demand curve dalo tolar pine nami ahi asu himane elasticity ki hoise komi goi ase. Okay, So কিবা যদি প্ৰশ্ন আছে সুধিব পাৰা, you can post to me. With this, we came to the end of this session. Thank you so much. Have a good time.